a quotient of complex number in standard form. Look at the first problem, 10 divided by 3 plus I. So what we have to do is we have to multiply this fraction by its complex conjugate to make the I disappear in the denominator. So that means when you reach to your final answer, I do not want to see an I in the denominator. The way we do this is we multiply its conjugate. Conjugate means you have opposite sign. So this is a plus and then this is a minus. So since we have to multiply this fraction by 1, then you have to write 3 minus I on top. So we take this fraction, multiply by 1. I didn't change the problem. Now, do we care about having an I in the numerator? The answer is no. So whenever I give you a quotient and you see an I in the denominator, just do your job to make sure there is no I in the denominator. What's in the numerator, I don't really care. All right, so let's go ahead and do the multiplication. The top we have 10 times 3, which is equals to 30, and then 10 times I is equals to 10I. You distribute the 10 to the 3 and the I. And then the denominator, 3 times 3 is equals to 9, and then minus 3I plus 3I, and then minus I squared. Do you see that once you multiply the complex conjugate, these two terms will be cancelled, right? And then the top, you have 30 minus 10I, and then the denominator, you have the I square. So the I square is equals to -1. So I square is equals to -1. So you have a 9 minus -1, which is equals to 10. And then as a result, that is equals to 30 divided by 10 minus 10I divided by 10. So this is a 3 minus I. This is a complex number in standard form, and you don't see an I in the denominator. Okay, moving on to the next problem. Let's try the 2 minus 4i. I'm going to switch to a different color for every new problem. So 2 minus 4i, and then divided by 3 plus 5i. Okay, look at the denominator. You have a 3 plus 5i. I need to get rid of that. So you have to multiply its complex conjugate, 3 minus 5i, top and bottom. The red is 1. When you take a fraction times 1, you don't change the fraction. Okay, what's on top? The top is 2 times 3 is equals to 6. And then 2 times minus 5i minus 10i, negative 4i times 3, negative 12i, negative 4 times negative 5, 20, and then you have an I square. And then the bottom, 3 times 3, 9, and then minus 15, plus 15, and then minus 25i square. And then what do you have? The top, you have a 6, minus 10 minus 12 gives you a minus 22. I, and then you plus 20 times -1, because I square is equals to -1. Let me put this up here. So we have I equals to the square root of -1. I square is equals to -1. So I square is equals to -1. And then the bottom, you have 9 minus 25 times -1. And then what else? The top, you have 6 minus 22. That is equals to 6 minus 22. That is equals to -14. So you have a -14, and then minus 22i. That is the top. And then the denominator, you have a 9 plus 35. 9 plus 25, which is equals to 34, right? And then what else can we do? At this point, there is no more I in the denominator. And then you have to go like that. So -14 divided by 34. And then minus 22 divided by 34i. Of course, you can reduce the fraction for the first one. Why don't you divide the top and bottom by 2? So you have a negative. So this is a 7. This is a 17. And then minus 22 divided by 2 is 11. 34 divided by 2 is equals to 17. And then you have an I. So this is your answer in standard form. As you can see, there is no I in the denominator. Okay, moving on to the next one. The next one we have 9 plus 6i and then divided by 3i. Okay, what should I do for the denominator? So the 3i, another way to do this is you can move this a little bit. So there is no real number, right? You can add a real number to it. So let's say you do that, 0 plus 3i. So now you have a plus bi. So now you have a standard form. When you find the complex conjugate, you can do this. You can do a 0 minus 3i and then 0 minus 3i. How about that? So what is that equals to? The bottom is just 3 times negative 3, which is equals to negative 9, and then an I square. So once you put the I square becomes negative 1, no more I in the denominator. And then the numerator, 9 times negative 3, you have negative 27, and then I, and then negative 3 times 6 is equals to 18, and then I square. So the bottom you have a negative 9 times negative 1, and then the top you have negative 27i, and then minus 18 times negative 1. So therefore you have an 18 minus 27i divided by positive 9, and then you write 18 divided by 9 minus 27 divided by 9i. So the answer is just equals to 2 minus 3i. There is no I in the denominator. How about the last one? The last one, the 2 plus 3i is in square. Can we just multiply? Can the conjugate just be 2 minus 3i square? The answer is no. In the third case, you will have to fully expand the numerator. So let's do that in a different color. Which color should I use? I'm going to pick something else. How about we pick a purple? We pick a purple. So 4i, and then divided by 2 plus 3i square. I'm going to do this, 2 plus 3i, and then 2 plus 3i. I need to expand this first. And then this is going to be 4i divided by, that looks like a 41, right? So 4i, and then divided by 2 times 2, and then 6i plus 6i, and then plus 9i square. So that is equals to what? That is equals to 4i divided by 4 minus 9 is negative 5, and then plus 12i. There you have it, plus 12i. So now you figure out the complex conjugate, which is what? Which is you multiply, the denominator is negative 5 minus 12i, and then the top is also negative 5 minus 12i. So now you multiply this. So what is that equal to? Let's do it. Should be easy and fast. Negative 5 times negative 5, you have a 25. Negative 5 times negative 12, you have a positive 60. And then forgot the I. And then minus 60i. And then minus 144. And then I square. And then the top negative 4 times negative 5, negative 20i. And then negative 12 times positive 4, that is a 48. And then I square. Okay, so how about this? We move this over here, and then we keep on moving. The top, you have a I square, so that becomes a positive 1. So that will be a 48 minus 20i, because we let the real number itself goes first, and then followed by bi, right? And then the bottom, we have something big to cancel, so this is cancel, and then we have a 25 plus 144, you have a 25 minus 144 times negative 1, so that is 25 plus 144, which is 169. So 169, 48 minus 20i, and then we break this down into two pieces. 48 divided by 169, let's make that look like a 9, and then minus 20 divided by 169i. And then that's it. That is the answer to the last problem. All right. So if you like the way I explain math, give me a thumbs up, a subscribe, and I will meet you all in the next video. Take care.